GRE quantitative section. If you feel like you've been running a sprint, take a little time after this session to outline your study plan from now until test day. You really have covered a lot already, and in this session, we'll introduce just a bit more new content. The great thing is, of course, that strategically, we'll be using the exact same tried and true approaches you've been practicing all along. Here's the agenda for session 4. We'll start off by reviewing the exercise question from the preview video. You remember it's one of those classic GRE questions that uses two familiar geometric shapes in combination. That will set the stage, as you know, for our discussion of the geometry rules and concepts that show up on the GRE. We'll begin with a warm-up, doing questions from the exercises that appeared in your preview reading assignment. By now, you know how valuable it is to do that preview reading before class so that you can put your main focus on how the math content shows up on the test and really look for the strategic approaches that make quick work of the questions. After the warm-up, we'll cover geometry-based test questions. Geometry may seem like a school subject, but the test makers, of course, find ways to test it in quantitative comparisons, problem solving, all that apply, and numeric entry formats. Once we've wrapped up with geometry, the real fun begins. I'm going to have you complete an entire GRE quant section. We'll split it up into 2 batches of 10 questions each, but it will be the whole shebang. All the different question types with all the GRE math content on the table. And we'll do it with the clock running, just like on test day. At the end of each batch of 10 questions, I'll review the most illustrative examples with you. It's a chance for us to get the feel of tackling a whole section, just as you'll be doing in your practice MSTs between now and test day. At the very end, I'll spend a few minutes describing the test day experience and outlining what you can do to be absolutely confident, absolutely prepared. So that's a lot to get to. Let's get started. Think back to the preview for a moment. As always, the instructor there showed you examples of how the GRE tests and rewards your knowledge of a limited, targeted amount of math content. The 2 most commonly tested geometric figures on the GRE are triangles and circles. And the problem your preview instructor left you to try on your own combined both of those. Here it is. Don't let the fact that some problems have figures associated with them throw you off from using the Kaplan method rigorously. Just consider the figure as part of the information you need to analyze in step 1. Here you can see that the triangle is inside the circle. One vertex at the circle's center, the other 2 touching the circumference of the circle. The question stem gives you additional information about the circle. Its circumference is 15 pi, and the arc between the 2 corners of the triangle has a length of 3 pi. All of that information will prove to be important, but you need step 2 of the Kaplan method to know how you'll use it most efficiently. The question is asking you for a piece of information about the triangle. Specifically, the correct answer is the measure of angle A. Whenever the test gives you a multiple figure diagram, you can be confident that you will need to use the facts about one of the figures to get an answer about part of the other. Since the test is asking you about the triangle, you'll start your analysis with a circle. You know from your preview and preview reading that the relationship of an arc of the circle to the circle's circumference is proportional to the relationship of the angle creating the arc to 360. In this circle, arc XYZ is 3 pi, and the circumference is 15 pi. In other words, the arc is 1/5 of the circumference. That means that the unlabeled angle, XOZ in the triangle, is 1/5 of 360. 1/5 of 360 is 72. You can use your calculator for that if need be. Now look what's happened. You've gotten some much needed information from the circle and applied it to the triangle. Keep going. The internal angles of a triangle sum to 180 degrees. So here, 72 plus A plus B equals 180. Or in other words, A plus B equals 108. You're almost there, but the circle has one more important little fact to give you for that triangle. Look at the sides of the triangle. OX and OZ are both radii. Both go from the center of the circle to its edge. That means they're the same length. Got it now? Of course, angles A and B must have the same measure. After all, they face sides of the same length. and that means that each of them measure exactly half of 108 degrees. Thus, angle A measures 54 degrees, and the correct answer is A. Label the three angles in the triangle to confirm. Sure enough, 72 plus 54 plus 54 equals 180 degrees. Take a moment and catalog the rules we used to get that answer. There was the proportional relationship between a circle's arc and its circumference, and between the central angle that creates the arc and the 360 degrees in the circle. There was the definition of radius, reminding us that the two legs of the triangle were equal in length, and the rule stating that angles opposite equal legs of a triangle have equal measures. Finally, we needed to know the internal angles of any triangle summed to 180 degrees. That's a bunch of stuff, but each individual rule is really pretty simple. The GRE, even at its most complicated, doesn't venture into the world of obscure PhD-level mathematics. It builds challenging reasoning questions out of clusters of sort of down-to-earth fundamental rules. Nowhere is this more apparent than in how the test uses geometry content. And it's the job of the warm-up to make sure you're primed to use those simple pieces for the GRE questions to come. So let's get into the warm-up. Everybody stretch.